The second video on estimating roots is on estimating cubic roots, and this one should be shorter than the last. If you understood my previous video on estimating square roots, this should be a continuation of. And if you've not seen that one yet and you need a refresher, go back and watch the Unit 2 Day 5+ video on estimating square roots. This video will follow the exact same technique, which is to identify your perfect, in this example, cubes. You see I made a mistake there. So I've listed my first 10 perfect cubes. I have my question off to the side, and I'm going to demonstrate with one example only how to estimate a perfect cube, or estimate a imperfect cube, which would be considered an irrational number. So here we go. I recognize, just like I did before, that the 75 occurs between 64 and 125. And I know that the square root, or I'm sorry, cubic root of 64 is 4, and the cubic root of 125 is 5, and the thing that we're after is the cubic root of 75. Now, very much like before, I want to make sure we're clear. We are doing an estimate. This is an estimate only. It's a rough estimate. This is not really how cubic roots work. For that matter, it's not really how square roots work either, but it will give you a better than a guess version of the answer. And with that said, here we go. So I'm looking for the square root of 40, or the cubic root of 75. I know it's between 4 and 5. It's going to be 4 point, and I don't know what, so 4 point something. It sure seems like it's going to be closer to the 4 than it is to the 5, because the distance between 75 and 64 is a lot less than the distance between 75 and 125. So speaking of those distances, let's go ahead and figure this out. I'm going to do the same technique I did before. I'm going to take the maximum perfect cube, and I'm going to subtract away the minimum perfect cube. These are what I called before bookends. 125 minus 64. When I'm going to use multi-tier, I'm going to do 125 and 64. This is 1, and I'm going to get 61, and what I used before was 61 spaces. Now that's going to be my denominator, so I already know that the denominator is going to be 61. I know that we're between 4 and 5, so my whole number is a 4, and all I need to do is find the numerator. And to find the numerator, same technique as before, I'm going to take my value, and I'm going to subtract away the lower perfect cube. So 75 minus 64 is, well, 75 minus 64 is 1 and 1, so it's an 11. So I have 4 and 11 61sts. Now I'm not going to pretend that's very pretty, but we put 11 on the inside, we put 61 on the outside, we add a decimal and some zeros, we add a decimal, and we're going to get some numbers here, and that will be sufficient for our answer. And our answer will therefore be, when we plug this in, it'll be 4 point whatever we get. And as I mentioned before, there's no real reason to go to multiple decimal places. The third one seems like overkill. For a method that's meant to be a quick estimate to start with, I don't feel like doing 3 different layers of long division seems reasonable. What most of you will do is you'll get your first number, you'll get your second number, and then this one will round the first. The hundredths will round the tenths, either up or leave it the same, and then your answer will be pretty good to 2 decimals. Sorry, to 1 decimal. So that's it. You identify your perfect cubes, you find out where your number falls on the list, you find out how many spaces exist between your bookends, you figure out how far your number is along from the smallest up to your number, and you create your fraction. To finish, your fraction becomes a decimal, and you do some rounding, and that's how you estimate cubic roots.